given an array nums of size and return the majority element. The majority element is the element that appears more than half the times. So nums, it's going to appear. So if you have 3 here, it has to be more than half of that. So half the times you may assume that the majority element uh, always exists in the array. So there it will always exist. So there's no need for any edge cases. So we see that in this example we have our nums array, and we can easily say it's 3 two times and 2 one time. So 3 is the output because that's the most element. That's the element that appears the most. And example 2, we have nums array and counting. We can see that 1 2 3 4, and 1 has 1 2 3. So 2 is the most in our nums array. So we can solve this a couple of times. This can be solved a couple of ways. Number 1, we can assign a candidate to the most appearing candidate. We can assign a candidate a variable to the most appearing number then as we increase our count, time complexity of O of n. And since we're only using a candidate variable, and also count will be so, and count, no, time complexity O of n, and space complexity will be O complexity equals to O of 1, since we're using the same variable, candidate and count. I know. So number 2, we can sort array, then choose choose the median number, since the element will appear more than half times. Time of O of n log n. So we're using the sort array, and we also loop to it. That's n of log n, and going to the loop, that's n of n, and combined is O of log n of n log n. Space will be O of n. 3, we can go to loop count elements in data elements of each num. We can count number of each num and store them in a data structure. Then choose the most appearing, and that'll be all of time of all of n space of all of n. So we're going to choose this one. It's the most efficient. So let's make our candidate variable. Candidate will be candidate. Will be none thus far, and then count will initialize it to 0. So now let's go to the loop. So iteration. So for num and nums, if count is equals to 0, which it is so far, let's go ahead and make our candidate equals to that num. If candidate hold on. So if candidate is equals to num, let's add let's make count. Let's add the count. Let's add 1 plus to account, and else meaning it's not equal to the num. We take the count, and count will be equals minus 1, and that's it. Candy date. So let's see if no, if count is equals to 0, which is so far, and then we for example here in this example we made it initialize it to 0. So if num is equals to 0, which it is, candidate will be equals to 3, and so we move on to the next num. Boom. So for nums, candidate count is not equals to 0. Candidate is not equals to, the num, the candidate is not equals to this, so we'll subtract 2. Subtract 1, and then so this will be 0 again. Then we move on to this. The count of the count will be 0 again. From 1 from this, and then we go to the next loop, and then if count is equals to 0, which it is, and then candidate is equals to num, and that's how we get that as 3. So that's it for this problem. Let's see if it works. We'll figure this. And let's submit to see if it works. And it's been able to work quite efficiently. Let's see. Time complexity over n. Space complexity of 1. And that's it for this problem.